Hey, future medics. Today we are breaking down the Krebs cycle, the second step of cellular respiration. And now, here, it's not about making a large amount of ATP, but it's more like the prep station in a kitchen. You have to cut up all the vegetables and all the meat and make sure everything's marinated for dinner service later so everything can just quickly be put together. That is what the Krebs cycle is. We don't make a whole lot of energy here, but everything is broken down so later we can. So, this is the inner matrix of the mitochondria. And this is where a lot of energy processing takes place. And the pyruvate, the pyruvic acid that we made in glycolysis, ride the little conveyor belt to the mitochondria. And this is where we go through a series of chemical reactions that you do not have to memorize, and we break things down. So those pyruvate are broken down into 1 ATP and 3 carbon dioxide. And the Krebs cycle is a wheel. And for each turn of that wheel, that is the products that we get. 1 ATP, 3 carbon dioxide. Remember, from that one glucose molecule in glycolysis, we made 2 pyruvic acid. So we're going to have 2 turns of the wheel for a total product of 2 ATP and 6 carbon dioxide. The carbon dioxide are then, it's then taken to the lungs and we breathe it out, which is important later when we talk about capnography. But for now, I just need you to know the products that we get out of the Krebs cycle. So let's review what we've got so far. From glycolysis, we got a net of 2 ATP. From the Krebs cycle, 2 ATP. So for a total of 4 ATP in the first 2 steps of cellular respiration, that's not a huge payout, especially when we know glucose contains a large amount of energy. So the point of the Krebs cycle is to gather the resources, package them nicely, and push them forward to the electron transport chain where they will all be put together for a big payout. The important part is that this step requires oxygen. The Krebs cycle is an aerobic process. Here's why you, as a paramedic student, should care. So we know this is an aerobic process, and if we don't have oxygen, we fall back onto the backup generator, which is glycolysis, which is an anaerobic process. And that is at the heart of lactic acidosis because we get that terrible buildup from glycolysis. There's tons of waste. And this results in altered mental status, organ failure. And we see this whenever we have patients in respiratory failure, sepsis, cardiac arrest, because that causes them to be in an anaerobic environment. So when we are giving patients oxygen, when we are fixing their perfusion problem, you are helping the body shift forward into an aerobic state. So hopefully we stop getting so much waste and further poisoning the system. So the Krebs cycle doesn't give us a huge energy payoff, but it does set everything in place for a big one later, which is important. So I told you I'd make it easy. You've got it. I know you do. You're doing so good. We're going to move forward into the last stage of cellular respiration, and you're doing fine. I know you are. I believe in you, even if you don't believe in yourself right now. I get it, but I will see you soon.